Good afternoon. So I'm just going to kind of go through those two questions about the graphing for you today on page 421. Okay, no worries. It is seemingly simple, but it's not necessarily so because you still have to be able to use the equations and stuff. So I'm going to kind of walk you through it and kind of give you an idea of how you look at them. So the first question there number 7 talks about the fertility rate of Canadian women over 40 for several years after 1977 is shown on the table on the right. The rate is the number of babies born on average per group of 1,000 women. So there we have years after 1977 goes from 0 to 28, and then the number of births is on the right. So what I'm going to do is I'm going to set up my window. So I'm going to click on the wrench here to set my window up in Desmos. And I'm going to, looking at the rates of births per thousand, it goes in the 3s and the 4s. It goes all the way up to 7 there. So I'm going to just kind of put my window from 0 to 8. Okay? And that's going to be the rates of the birth. So that's going to be my Y. I'm going to choose that as my Y. Okay, so the year is going to be the X value. I'm going to sub that in, and the actual result is going to be the number of births per thousand, which is going to be my Y. So I'm going to go from 0 to 8 on the Y. Okay, and then on the X-axis, I'm going to go from 0 to about 30, as it's got a table all the way up to 28 years. Okay. So that kind of gives me how big I want my window to be. I'm going to hide this. Now what you do, the first step always with Desmos, after you've kind of figured out your window, is then you click up over here to add an item, and you want to add a table. Okay, so now we have an X1 and a Y1 scattered plot table. So now we're going to plot, X's are going to be the years after, all the way down to 28, and Y's are going to be the rates of birth. So I'm going to go ahead, plug one in, 1 and 3.9. Okay. Then I go to the next one that's on the table is 3 and 3.3. Then I got 4 and 3.4. Rather than you sit here and watch me plug all these in, I'm just going to pause and I'll plug them all in, and then I'll come back and talk to you about that if I can find where my recording is. First of all, I got to get the preview up. Sorry, let me do that first. Okay, so I'm going to go ahead. So then, what you would do, after the 4, you got 5 and 3.3. Okay, so I'm going to go ahead and do all of this manually, and then I'll get back to you. Okay, so I'm just going to pause for a second. Okay, so I've plugged it all in here. You can see I've got it all the way from 1 all the way down to 28, and I plugged all the numbers in. The Y value being the number of births, the rate of births per 1,000 females. Okay, so now what they say there is they say, okay, use quadratic regression to interpolate 2 missing data values. So when they say quadratic, what they're meaning is they got to use the quadratic equation. Okay, so quadratic equation, that's the ax squared plus bx plus c. Okay, so what we do then is we go down here, click on here, and we're going to do an approximate line, a best fit curve. Okay, so when we do that, we go y1, okay, the subscript 1, to represent. Why do we use y1? Because we want to talk about this line. Okay, and that's going to equal. Now we don't use the equal sign, we have to use the approximate sign, which is above the quote point on your keyboard, that one there. Okay, and that's going to be ax1, ax1, and now to get it to squared, you hit shift and 6, and that gives you the squared, and then you can put 2 there. Now you've got a quadratic shape there. Okay, then you push forward on your keypad to go 1 up, and then you go plus bx, b, and then x1. plus C. Okay, so there is the quadratic regression of a best fit curve. So that represents, okay, remember that here is the equation right down here, ax1 squared plus bx1 plus c. So a is this number here, b is this number here, and c is this number here. If they asked you for what is the equation of quadratic regression, then it would be 0.9843 x squared, or sorry, not that, sorry, 0.007, don't ignore this number, that means nothing. 0.0744744, then b would be minus 0.0640 plus this number. Okay, so now then they say interpolate. Interpolate means finding a missing value. So interpolate means to find a missing value. So you want to find a value at 2. So if you look at the table there, 1 and 2 are missing. Okay, 7 and 8 are missing. Okay, 12, 13 are missing. Okay, so if we wanted to get 12 and 13, we could then just go along here and wait till we got to 12 to get our result. So I would just slide it along here, slide it along. Okay, a little bit too far, a little bit too left. Okay, right on 12. So there would be my interpolation. So at that point, 12 represents 3.825 births. Or for rounding it off, 3.8 would be an interpolation. Okay, you could also do 13 is missing as well. So just move it up a little more until you get to 13. So 13 would be about 3.947, or about 3.9. Okay, and you could plot that, if you printed this out, you could do that by just interpolating, by putting a line, so drawing a line down here, and then one that goes straight across here, like doesn't follow the curve, but goes up to that point, okay, where it intersects. So that's how you interpolate. Compare the interpolated values to the actual values in the table below. Okay, so we look at the tables below. Their number 1 was 3.9. Well, let's look at their number 12 was 3.8. We got that pretty much. Their number 13 was 3.9. That was good. Well, if we did 1, what was 1? So 1 would, for us, $3.465. So that's a little bit off. 2 would be about 3.4. That's pretty close. 7 is supposed to be 3.1. Let's see what 7 is. Okay, 7 looks like 3.48, so it's a little bit low. 8, a little bit low. Okay, 12 and 13 we did. 18, which is supposed to be 5.0. See what 18 gives us. $18 was 4.8, so it's fairly close. 19 was 5.3. What do we get? A little bit low for 19. Okay, so that's all you had to do for that comparing. Okay, hopefully that helps you out a little bit. Okay, number 8. 225-liter hot water tank sprung a leak at t equals 0 minutes. So that means we're going to use t as our x-axis, okay, and v is going to be our y-axis, okay. And they're saying plot the data in a scatter plot. Determine the trend. Okay, so let's do that. So let's eliminate this one. Hopefully that helped you. So what we're doing, Isha, when we're doing this stuff is when we're trying to find that point on here, what we'd do if we were doing it by paper is we'd just draw a dotted line across and a dotted line across and read it off the graph. Here with Desmos, we could just move the point along the curve and it helps us that way because it's a computer. Okay, so we'll eliminate this table here. And we'll eliminate this equation here. And we got one there that's still there for whatever reason. Here, let's just do a new one. Just do a new, oops, went too far back. All right, so we're going to do number 8 now. Okay, so maybe if you have a Chromebook handy, you can pull that out and do it along with me. So I'll plot this. This one doesn't have as many points to put in. Okay, so if you want to pause the vid and go grab one if you don't have one handy. Okay, so if you want to do this one with me, get out your Desmos, get to the page, go to the square, the wrench here. Okay, and we're going to put the time is going to go on the x-axis. It goes from 0 to 40 seconds. So we're going to put our x-axis from 0 to 50 because we're going to add a few seconds on there. So you go up here and go 0 to 50 in there. Okay, the y-axis, if you look at the y-axis, it goes from 225 all the way down to 23. So we want to go from 0 to maybe 250. Okay, so we'll go 0 here to sorry, I'm in the wrong spot. Keep the 50 there. Sorry, I got to move it down here. So 0 here. And then over here, we're going to have to go up to around 250. That gives us our window where we're going to have our graph come out. So the next thing that they say is plot the data in a scatter plot and describe the trend. Okay, so if we take the data, we're going to go over here, hit the plus sign. Okay, add an item, go to table, and you should get this coming up, X1, Y1. Okay, so on the X, we're going to go 0, 5, 10, 15, 20, 25, 30, all the way up to 440. Okay, 25, 30, 35, 40. Now we could do each point as we go, but I'm just going to put all of those ones in because it's easier for my old eyes. Okay, so the first point said the volume was 225. So the volume is going to be represented by our y. Okay, so it's going to be volume equals some function of time. So go ahead, put 225 in. Okay, there's our plot right there, right along 0. Okay, that's how much is in the tank, right? Okay, and then it's 188. Okay, then after that, it's 155. Then after that, it's 124. Then after that, for 20 seconds, it's 100. 25 seconds, it's only 72. Then 30 seconds, it's 55. Okay, notice it's kind of flattening out a little bit there. 35 seconds is 36. And finally, for 40 seconds, we get 23. Okay, so when they say to describe the pattern of data, so look at your Chromebook there, or my screen here, and you can see that it's kind of going down, and then it sort of curves at the end, just like a quadratic might, like a U, right? So that suggests that you would have some quadratic regression in your possible thing. So the data says that you're losing volume, but as you get now near the bottom, the slope seems to be getting less. It seems to be going and flattening out, right? Okay, so that's part A. So that is what it says. Determine the equation of the quadratic regression function that models the data. Okay, this is where we need that ax squared plus bx plus c, okay, for quadratics. So what we do is we go underneath, we click here, okay, we put in y, 1, so that's a subscript like that. We use that approximation sign, like that's above the tab key on the keyboard here. I don't know where it is on a Chromebook, but hopefully it's there. Okay, and then we got to put in ax1 squared. So shift above the 6 squared. Okay, plus bx1 squared needed plus c. Okay, so now you can see it's trying to go through all of the points there. Okay, so now down here, when you're looking at it, this is your equation that you're approximating here. Quadratic always has a squared term, an x term, and a constant. Okay, even if there's zeros. Okay, and don't worry about this. This is just some statistical data we don't need. But here are the parameters of A, B, and C. So now if we're going to get the equation, so I'm going to move this over and get my Blackboard open here. So let's get that started up here. Okay, we'll wait till that opens up. And what we're going to do is we're going to input these 3 numbers into A, B, and C to get our equation. And that'll be the answer to B. Determine the equation of quadratic regression function that models the data. Okay. All right, so we're waiting for that Blackboard thing to pop open here. Still grinding away. Still grinding away. I'm going to move this over so we can see it. Slow, computer, slow. Okay, so once that pops open, I'll show you how we write the equation. Okay, so now here it is. So I'll get my marker out here. So all I need to do to get the quadratic regression function is to replace the A, B, and C values from the Desmos. So I'll bring it back over so we can see it. So what we want, or what we have, y equals, now we replace the approximation with equals ax squared plus bx plus c. So now what we got to look up here, and I'll put this up on screen so we can see it. Oops, that's my email. Wrong one. You already know what the email says because you sent it to me. Okay, so here we are. And right here, make this a little smaller. Bring it up here. Okay, so now we can see that my A is this number right here. So if I write it out, it's going to be y equals, okay, now that A disappeared because I had to write there. So I'm going to put 0.6494. 0.06494 x squared. Okay, because that was my A value. Now I'm going to do my B value. So we'll bring that back up so we can see it. Okay, my B is negative 7.651. What do you need?
For the formulas.
Oh, that one? It's over here.
Oh,
It's right here. Okay, so the B value, we're going to put negative 7.651. Okay, x. Okay, plus C. Now we have to go look up C. What was C? Okay, we put that, we go. Okay, C is 224.8 or 224.9. Okay, so we'll move this over out of our way. So 224.9. basically 225 because that's what the 2.9. So that's our equation of quadratic regression using the quadratic formula. Okay, so that's what they asked us to do in B. Now it says, determine when the tank was half full. So the easiest way to do this is to know when the tank is half full. So 225 liter tank. So we have to divide that by 2. Okay. Let's see here. Got it? Okay, so half full would have been half of this, so we got to divide it. Sorry. 225 divided by half, that's 100 and something down the middle. So 112 and a half. So we're going to have to go and find on our graph. We could use this quadratic regression line. We could put this in here and try to figure out x, but that's pretty hard to do. It's much easier if we use our graph. So we take our graph over here, and we want to find the time, the x point, when we have 212.5 for y. So go here and keep going up the graph till you get 212. Or sorry, 112. Why am I saying 200? So 112.5. So 112.5 is about right there. Okay, so 17.2 seconds. Okay, so the answer is approximately 17.2 seconds, or 17.2 minutes. Not seconds, it's minutes, I guess. Yeah, it's saying minutes. So 17.2 minutes. So we could say at 17.2 minutes, tank was half empty or half full. Okay, now what we want to do is what we need for the last one is determine when the tank was empty. So that means when there's 0 for y. What is the y-intercept? So that one, not that one. I got to get back to decimals. All right, there we go. Okay, so we got to kind of go over a little more on our graph. So what we want is we want to see when it hits the y-axis. Okay, when does it get to be 0 down here? Okay, so this one, we're going to have to kind of, when is this hitting the 0 mark? Okay, so we're going to zoom in, and zoom in to see. Okay, so right there, 56.22 minutes, and also over here, but this is back up on the upswing. So it's probably going to empty here first, and then once it's empty, it's going to stop, right? It's not going to it's not going to go into negatives, and it's not going to go over here. So the first point where it gets to be 0 is right there. You can even see the dot that the Desmos makes. That's the y-intercept. So 56.22 minutes would be when it's approximately empty. Okay? So if we go back to our here, D would be 56.22 minutes. Or what was it, 55 or 56? I can't even remember now. Let me look. Oh yeah, 56.22. $56.22 minutes. Okay, now if you're not right on with the back, if you're a little bit off, that's fine because, graphs aren't going to be perfect. Let's see what the back says anyway. I never even looked. So they're saying what did they give you there? That was for chapter 6. Yeah, so they rounded theirs off. So yours was pretty close. They say 56.2. So we were pretty close. So that's kind of how you do those ones. Okay. Hopefully that helped you. I don't know. You let me know whether that improved for you or not. If it's still tough, there is one quadratic regression on the quiz that I'm going to give. So you can use Desmos to help you out. Okay, but just do some practice. If that doesn't help, I'll see if I can the one that I give on the quiz is a little simpler than that, but basically that's how it works. There's one linear one, and then there's one quadratic one. Okay, so best of luck. I'll send this off to you. Hopefully it helps you out.